concerning earthquake forecast. Breakthrough could hand Americans a vital 5-day big one warning. Scientists may now be able to predict earthquakes, including the big one, a whole 5 days in advance in what could be a major breakthrough in order to save lives. Sean Martin reports this. Researchers have so far been unable to predict an earthquake, the timing when a devastating earthquake could strike, putting millions of lives at risk. But researchers from Russian scientists show that there may be some signs deep below the Earth's surface when a major tremor could be coming. Scientists analyzed internal gravity waves, IGWs. These stem from fluids in the Earth's interior. The finely tuned satellites can detect these small oscillations, and researchers from the HSE University and RAS Space Research Institute, both in Russia, IKI Institute, both in Russia, analyzed data, concluding that they are able to predict an earthquake. These physicists chose 3 earthquakes to analyze. The Uzbekistan that took place May 26, 2013, in Kyrgyzstan on January 2007, and in Kazakhstan, January 28, 2013. These 3 earthquakes. 5 days before these earthquakes, there were signs. There were slight IGWs, internal gravity waves, which presented themselves by fluctuating air mass. According to the research published in the journal Doklady Earth Sciences, there were thermal changes in the middle atmosphere stemming from the lithosphere, the outermost part of Earth's crust, which preempted the tremors. Okay? What happened was that there were lithosphere atmospheric changes, thermal changes in the middle of the atmosphere stemming from the lithosphere, the outermost part of the Earth's crust, which preempted the tremors. The team said that the internal gravity waves began to grow 5 days before the tremor, peaking 2 days prior to the event. Sergei Popel, professor of the HSE Facility of Physics, he was the head of the IKI laboratory, one of the authors of the study, said, "This means that processes occur in the Earth lithosphere, the development of which gives us rise to connective instabilities in the lower atmosphere. They are the cause of the internal gravity waves in seismically active regions. Internal gravity waves, once they reach the mesosphere, can be destroyed. When this happens, the IGW energy, the internal gravity wave energy, transforms into thermal motion, which affects the temperature. The new discovery could help scientists predict when a big one might take place, and the big one is an impending massive earthquake, which will inevitably, of course, one day devastate California, as the big earthquakes of the past in California show us. Now, tension has been building along the San Andreas Fault for centuries, and experts predict the ground-splitting quake for when the fault line finally ruptures. U.S. Geological Survey said it will be at least a 7.9 on the Richter scale and will leave a trail of destruction. If scientists can use this latest technique to predict the big one, then it could save up to 40 million lives in California, because they will be able to, for example, evacuate the areas. But other scientists believe there is no way that earthquakes can be forecast. John Bellini, the geophysicist at USGS, says that we cannot predict or forecast earthquakes. Well, that was before all this came about. Now, sometimes before a large earthquake, you'll have a foreshock or two, but we don't know there are foreshocks until the big one happens, he says. USGS completely denies that earthquakes can be forecasted, writing on its website, neither the USGS nor any other scientists have ever predicted a major earthquake. We do not know how, we do not expect to know how, any time in the foreseeable future. Scientists previously found a link between the climate and earthquakes, mainly climate change and the melting of the ice caps. Now, a team of researchers from the Leibniz University in Hanover, Germany, investigated a major fault between a zone running across Denmark over the course of 2.5 million years to 12,000 years ago at the end of the last ice age. The team found, as the ice melted, it affected the sediment deep beneath the surface, which essentially reactivates the fault line, according to the research led by Dr. Christian Brandes. Scientific journal Science wrote, the 115-kilometer-long Austening thrust underwent a series of faulting movements over a 140 million year period, ending about 16 million years ago. The team also shows that movements along the fault also occurred very recently. Modeling these structures has enabled Dr. Brandes and his colleagues to demonstrate that the Austening thrust was reactivated at the end of the last glaciation about 12,000 years ago. And he said that the fault reactivation was accompanied by earthquakes, of course, which the team identified from the soft sediment deformation structures that developed in the area. The findings imply that an earthquake, which took place in this region during the autumn of 1612, might have triggered due to the stress changes in the Earth's crust caused by melting ice sheets. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.